we'll see how exactly we can build the regression analysis using linear model. So linear in a sklearn, we have the multiple models like linear models and non-linear models. So for now, we are just understanding all the linear models. So out of these linear models, we are just considering the linear regression model. So linear regression can be a multiple linear regression or maybe a single linear regression. But at the end, formulation and calculation for the multiple and single linear regression is the same. Linear regression, you can, this is our one of the object which we have, they have already defined inside that particular library. So you can just define that object is equal to lm is equal to linear regression. So this is how you have imported or maybe created an object for the linear regression using the library. So this is how you have initiated. So we have already seen the object oriented programming. So in object oriented programming, whenever we want to initiate or maybe define one of the object or maybe one of the class, you can consider this is the one of the class, and if you want to initiate that class, this is how you can do. So we have already seen that in our object oriented programming, how exactly we can initiate the object or maybe a class, and that particular object or maybe class you can define to the any variable. So you can define either l or maybe lm, so this is up to you. But this is something that you won't be able to do the any mistakes over here. So this is the class name, you should define it properly. And if I want to train a model using the training data set, this is the simple command which you can use, the lm.fit. So lm.fit on xtrain and ytrain, it what exactly it will do, it will just basically go and fit the model. Fit the model means it will just try to find out the best line over here. So this is like OLS method we usually use to find the best fit line. So best fit line, you can see the term over here as the same as a fit. So we will just try to find the best fit line. So the same thing, if we want to implement in a Python, we just need to use this fit function. So for the fit function, we need to pass the x train and the y train. So you have already seen over here, this is your x and this is your y. So this is the two value you need to pass when you want to fit any or maybe choose any specific and best value. So this two data set you need to pass. So similarly to the fit function in this sklearn library, we are going to pass our training data set uh, of the dependent variable and of the independent variable, and then we are going to predict it. So as I said, what exactly we do over here. So we just use the train X train dataset, Y train dataset means history dataset. And based on a history dataset, we keep the some Y test aside. And for that particular X test, we just try to predict the values, and those values we can represent it as a Y predicted. So this is what we have done over here. So over here we have fit our model, means we have choose our best line using OLS method. Over here you can see, then using the prediction command, predict command, we have predicted the values of that particular X test. So for that, we have predicted the some values. You can consider some values, something like over here. So it can be a Y predicted, and we for that you have used this X test value. So Y predicted, this is what you have predicted using this history or maybe a black box kind of thing. And once you predict the y predicted, and you already have this but you have kept this hidden, and then you are going to consider these two values together to see how much like is your prediction is correct or not. So this is how we have predicted this. So you can see that whenever I see over here as a y predicted, you will see the 8 values because your x test is 8. You can see over here as a y test. You can also print that y test over here. And this is your x test. So X test is nothing but, and whenever I'm saying that the X train and Y train, so here we have, you have the entire data set over here. So in machine learning, you won't be able to consider the 80% means all the top 80%. So this is not how you actually divide your data set. You actually randomize your data set. So this particular value could be at the over here, this could be over here. You just shuffle the entire data set, or maybe you just mix, just like cards. Like suppose we just understanding the card game, we have the 1, 2, 3, 4. So all those numbers are like are properly managed. But if we just shuffle the cards like while playing the card game, so all the numbers could be a mix match together. So this is what we do using this sklearn library. So this sklearn library is not actually only splitting the data set, it's actually just a mm, Uh, yeah, it's actually just shuffling all the data set together and just giving you a training and testing periods. So you can see that if you want to check, probably over here you can see the below values is something like that one. So these are the seven values you can consider, 1, 2, 3, 4. These are the seven or maybe eight values of the bottom ones, but you won't be able to see these eight values in your text, X test and Y test. You can see that over here you have the something different values in the X test. So this is your X test, technically like all the bottom seven or maybe eight values. But once you do the shuffling, all the values could be combined together, and you are just able to extract the seven values randomly out of it. So this is not matching together. So this is your X test, which we have over here. In the entire data set, you can consider this one, and then you are going to predict these values. So this is your Y test, which is already over here. This is the hidden values, and based on a X test value, you are just going to predict this Y predicted values. So this is the X test, this is the Y test, and for that you have or maybe you got this Y predicted value. So this Y predicted looks like, you can see that actual value is 1, but you have predicted this as a 14. Then actual value for that particular sales. So this is the sales data set. So for the X, you can consider over here, for the first value X, the actual value, like this is the sales data set. So using the sales data sets, we are going to predict the advertising. Uh, so for the advertising, this is your actual value. So these are the two values which we have here. And then the predicted values using your model is this one. So this is something is not a good values, or maybe whatever you have predicted is not actually close to your predicted value. So this is something else. You must have to predict something close to one, but your linear model or maybe whatever model you have built is not a good model, or maybe whatever OLS method or maybe a best line which you have choose over here is not actually a good line. That's why your predicted value is something different and your actual value is something different. So you can just have the understanding of these values. Like over here you can consider the another value. So we'll just consider the two values, just remove, like just to remove the confusions. So this is the actual value and this is what you have predicted. Again, this is the actual value. Let's see what you have predicted. So it's more like something. So looks like you have predicted correctly second value. Only the first value you haven't predicted correctly. So this is how you can check your predicted values and your actual values. So this is what previously we kept hidden, and using the X test, we try to predict these values. So similarly, you can see over here the relation of the predicted values and the actual values. So you are, and this is the something sales data set which you are going to consider, and using that sales data set you are going to predict the Y values of the advertising, this one, and then you are going to check what is your predicted value and what is your actual value. So this is how you can just have a look into that. Then you will able to understand what was your actual value and what was your you have predicted. So as I said, whenever we just build a model or maybe fit a model, we just try to find out using a best fit line. So once we find the line or maybe choose line, this will give you a two things. One is the slope. Slope is nothing but this one, and then another one is the intercept. So these are the two values which you usually get out of it. So if you want to check what exactly the values you got when you fit this linear model or maybe linear regression using this LM, if you want to check that, you can just simply print lm dot coefficient and lm dot intercept. So for the coefficient, you can consider this as a, and for the intercept, you can consider this as a b, because we have defined two variables with the name of a and b. So estimated slope value is this one, and estimated model intercept value is this one. So these are the two value which you have received or maybe which you have got using this prediction of this one. So these are the values which you are going to use to calculate. Whenever you pass this value of x, means sales value, you will predict the y as an advertised value using this slope and intercept. The slope and intercept value are unknown values that we need to predict or maybe we need to calculate or maybe estimate using a linear regression. So we have calculated or maybe estimated that value using this LM fit. So LM fit is nothing but it's actually fitting or maybe a training your model on a trained data set, and then this is actually giving you the predicted value as well as the coefficients of those lines. So these are the coefficient of the estimated lines. So your line could be something like that: y is equal to uh, the slope plus x minus, or it's actually multiplication of that particular slope, x multiply by slope, and then plus we are actually doing the intercept, but value of that is something like -1, or maybe if you want to reduce the confusion, you can consider something like that. So this is your equation which you have got over here, like y is equal to mx plus b, or maybe y is equal to beta 1 x plus beta naught.